Hello students, this is Afrit Tasildar. So the next part is continuation part, algebra of continuous function. In this you have theorem, few theorems are there, you just need to remember it because that will be useful in your exercise. So the first theorem is, if f and g are two real valued functions of a real variable x which are continuous at x is equal to a, then a, we have f plus g is continuous at x is equal to a. B, f minus g is continuous at x is equal to a. C, f into g is continuous at x is equal to a. D, f divided by g is continuous at x is equal to a. This thing we have, we'll start with the proof. Proof, whatever they have given in the statement, I am writing it. That is, since f and g are continuous at x is equal to a, which they have already given. So according to your continuous function, definition of continuous function, what it tells, limit f of x as x tends to a is equal to f of a, and limit g of x as x tends to a is equal to g of a. Here why f and g? Because here we have taken two continuous function, so definition applies for both. Same definitions, we are just writing it. Now we are considering first part. So consider, they have said f plus g. So limit f plus g as x tends to a of x is equal to, how we are writing it, how it is, f plus g of x, right? So I am multiplying it both, f of x plus g of x, the same thing I have written. After that, limit is outside, so multiplying this, limit of f of x as x tends to a plus limit of g of x as x tends to a. Say according definition, limit of f of x as x tends to a is what? F of a. So directly I am writing f of a. Limit of g of x as x tends to a is what? G of a. So directly I am writing g of a. In this both a is common, so f plus g of a. So limit f plus g of x as x tends to a is equal to f plus g of a. Hence the function f plus g is continuous at x is equal to a. In the same way, the second one, which it was f minus g, the same we are considering, consider limit f minus g of x as x tends to a. In the same way, multiplying my x to both f and g, because here x is as a common. So f of x minus g of x. See, limit you have to keep it as it is. Later for limit we are multiplying. Opening up the bracket, limit f of x as x tends to a minus limit g of x as x tends to a. So limit f of x as x tends to a is what? At the starting only we have written as f of a minus, as it is, limit g of x as x tends to a is what? G of a. So this is equal to a common, so we can write it f minus g of a. Same way third and fourth, you guys do it, it is there in the textbook. Next theorem, the heading is continuity of a composite function. So theorem 2, if f and g are real valued functions of a real variable x which are continuous at a point x is equal to a, show that g of f, it is like g composition f, composite function, we tells it like that, g composition f is defined at x is equal to a, then g composition f is also continuous at x is equal to a. Okay, so the proof, since f and g are continuous at x is equal to a, same, this will be a common because this is they have given in your statement part and it is definition of continuous. So limit f of x as x tends to a is equal to f of a, and limit g of x as x tends to a is equal to g of x. So now we are considering what they have given, limit f composition g of x as x tends to a. So composition, how we will write, limit as x tends to a, it will be f of g of x. See, composition will be always written like this, f g of x. No need to go in a deep way, it is just you should remember. Now here when you have f g of x, how you have to take, this tends to g of a you have to take. So it becomes limit f of g of x as g of x tends to g of a. So in place of g of x it becomes what? G of a. So then it becomes f composition g of A. How you had done f composition g of x, f composition g of A. Hence, f composition g of x is continuous at x is equal to A. Just composition part, when you have like this, so you should take f as a common and inside will be g of x. So first g of x you multiply, it is like that. If it is g of g composition of f, you would have written as g of f of x. It's just simple, just composition. This you have to remember. If it is f composition f, you should write like this. It is g composition of f, it is like this. No need to go in a detailed. Next we have theorem 3. Prove that every polynomial function is continuous. Polynomial function, you already know what we tell as a polynomial. So proof, let p of x be a polynomial function defined by, see here I have defined how a polynomial means what, p of x is equal to a naught plus a1x plus a2x square plus a3x cube plus a4x raised to 4, so on up to an x raised to n. This is termed as polynomial, right? You have studied about polynomials. You have a monomial, binomial, trinomial. So this we tell as, if we have till nth term or more than 3, we call it as polynomial. So where n belongs to, n means your n belongs to all natural numbers and ai belongs to our real numbers, where your an is not equal to 0. If your an, if it is 0 means this last term will be 0, right? So your an is strictly not equal to 0. Now what we are taking, let c be any real number. We are taking c as any real number. As in your previous theorem, we were taking as x real variable. Here we are just taking as c. Why? Because here already in x we have taken. So just for changing purpose, we are taking c. Then applying limit on both the side, your left hand side and your right hand side. So limit p of x as x tends to c is equal to limit, this whole comes in one bracket, a naught up to a n as x tends to c. So wherever x is there, it we are substituting c. So it becomes what, a naught plus a1c plus a2c square, so on up to a n c raised to n, which is equal to p of c. When p of x it is, it will be this. When p of c it is, the x terms will be replaced by c. Hence, p of x is continuous at x is equal to c. This is your third theorem. Whatever the theorems I have taught you, it is useful for you in the exercises. So please just go through it. No need of going in a detailing. Just how much I have taught you, just in that way, if you go it will be well enough. Go through the theorems and please note down the notes. Thank you.